Everyone, I'm Monica. I've been a software developer at Thoughtworks for the last 2 years, and before I used to be a telecommunication engineer, and I'm very excited to be here today. So by now you've been asking yourself, what innovative thing about container security are Marina and Monica going to tell me about? Well, sorry to disappoint, there is nothing new or innovative here, and probably some of you already know what we're going to share today. But that wasn't the objective of our talk. What we wanted to show today was that without having to be a specialist, because not Marina or myself are in this topic, anyone can and should take a few things into account when it comes to working with Docker containers. So we know software containers have become more popular in recent years as many organizations have discovered the benefits of containerization. Unfortunately, and as is often the case in rapid advance in technology, container security has been a bit neglected and is often an afterthought. So in this talk, what we wanted to bring, it was to bring to some light on the main areas of concerns that are associated with using containers and some of the practices to keep in mind to avoid falling into these traps. We choose to focus our talk on Docker because it is a widely used technology and often can be synonymous with containerization. But we're not by no means saying that this is the only option out there. So we would like to point out, however, that security is a huge topic. So there is no way we could fit everything, no, we will try to. And while this talk doesn't intend to be an exhaustive guide to Docker security, for that you should always refer to the official Docker documentation. We wanted to share some of the good practices that we've learned along the way and that we thought might help you as well. Before Docker, most organizations use virtual machines or bare metal server to host applications. From a security perspective, these technologies are relatively simple. You only need to focus on two layers, the host environment and the application, when hardening your deployment and monitoring for security relevant events. You also typically didn't worry that much about APIs, overlay networks, or complex software-defined storage configurations, because these are not usually a major part of virtual machine or bare metal deployments. So when talking about challenges of Docker container security being more complicated, it's largely because a typical Docker environment has many moving parts, which means there are more layers to secure. And those parts can include your containers, of course. You probably have multiple Docker container images, each hosting individual microservices. You probably also have multiple instances of each image running at a given time. So each of those images and instances needs to be secure and monitored separately. The Docker daemon, which needs to be secured to keep the container host safe, and the host server, which could be bare metal or virtual machine. And probably you host your containers in the cloud using a service like Elastic Container Service, and that is yet another layer to secure. So, and if there wasn't enough within Docker itself, you also have to worry about the overlay networks and APIs that facilitate communication between containers. And of course, any data volumes or other storage system that exists externally from your containers. So we know this all can be a bit overwhelming at first. We wouldn't know where to start either. But next, Marina will help us take a closer look at some of the areas we should be concerned about when securing Docker containers, so we can have a better understanding.
Cool. So I think I was having some problems with my mic volume before. So if there is any problems, talk up. If not, I'm just going to continue. Cool. So let's talk about the container lifecycle. So the process of securing your containers is something that you want to be continuous. So it should be integrated into your development process, and it should be automated so that you remove the number of manual touch points that there are. And you also want to extend it into the maintenance and operation of the underlying infrastructure. So this means you want to be protecting your build pipeline, container images, the runtime host, platform, and application layers. Implementing the security as part of the continuous delivery lifecycle means that you're going to be mitigating risks and reducing the vulnerabilities across what we would call an ever-growing attack surface. So now we're going to go through each step of the lifecycle to see what improvements you might be able to make. So one of the important parts of the build stage is that you want to be hardening your image. And a good way to get started is that you could use a linter for your Docker file. So this is a really useful tool because you can avoid making common mistakes, and you'll be following best practice guidelines in an automated way so that you don't have to know everything off by heart. We'll actually point out some of these good practices to you later in the talk. As for the linter, there are several places that you can actually add this into your process. So you can add it into your pipeline, which is something that we're going to be showing as part of a demo. And another option is to add it in as a pre-commit hook. But ideally, you want to be catching these common mistakes at an even earlier stage. So having it integrated into your IDE is probably the ideal option, but maybe not all tools are going to offer this. So you'll just have to find what suits you best and what works for you and your team. For image security scanning, this is a process where you find security vulnerabilities within your Docker image files. So normally the scanning works by passing through all of the packages and other dependencies that are defined in the container image file, and then to check to see whether there's any known vulnerabilities in those packages or dependencies. So while security scanning is a critical way to find security flaws that could lead to a breach, it is important to know that security scanning by no means is going to provide any full security coverage, because there are several potential security problems that the image scannings are not going to help you find, and I am going to point them out to you. So firstly, it's not going to be checking any security problems that you have in your container environment, for example, running your image as root, which we'll cover later. Scanning is also not going to check for insecure shared resources between containers, so such as storage volumes or networking, because they exist outside of the container image. It's also not going to find any unknown security vulnerabilities. So most scanning tools, they check against a public vulnerabilities database, and that's to determine whether a package has a security problem or not. So if there is a security flaw that's not been publicly disclosed, then the scanner's not going to be able to pick it up. And it's also not going to find any vulnerabilities that are not evident from the package name. So it won't find anything in packages that are not being publicly monitored for security vulnerabilities. So even though it should definitely not be the only part of your container security strategy, then image security scanning is definitely a crucial one. It is one of the primary means of defense against security flaws or insecure code with container images. So for us, we would say that it is a foundational part of overall Docker security, despite all the things it doesn't cover. Next, we'll look at multi-stage builds. So when you're building your application with your Docker file, there are loads of artifacts that are created that are only required during build time. So these packages can be things such as development tools or libraries that are required for compiling, or dependencies for running unit tests, or temporary files, or secrets, and things like that. So keeping all of these artifacts in your base image, which is going to be used for production, is actually going to create a larger Docker image size. And this can actually badly affect the time that is going to be spent downloading it, as well as increasing the attack surface, because there's going to be more packages installed. So the same is true for the Docker image that you're using. You might need a specific Docker image for building, but you're not going to need it for running the code of your application. So this is a good reason why Docker has the multi-stage build capability. It actually allows you to use multiple temporary images in the build process, and then keeps only the latest image along with the information you copied onto it. So this would result in having two images. The first one would be a really big, massive one bundled with loads of dependencies, and they're all going to be used in order to build your app and run tests and things like that. And then you'll have a second image, which is nice and thin in terms of the size of the image and the number of libraries. But it'll only have a copy of all the artifacts that are required to run the application in production. So that actually brings us to the next point, which is looking at the size of your image and where you're getting your image from. So the base images, basically. So when you start a project, you'll probably start your Docker file with the from keyword, and that's where you're going to be getting your base images from. And it's important that you get these from a trusted source, because that's what we need. So there are some basic indicators, as you can see on the slides, which can help guide you when you are trying to choose one. So we've used Docker Hub as an example, and usually it's a good bet that popular official images are relatively safe. So they'll have the official image stamp, and they'll probably often also have millions of downloads. Other good indicators are that the image is Docker certified or that the publisher is verified. And even taking it a step further, you can also check that the updates are being made regularly. Maybe 1 hour ago is very optimistic, but it is good that you're double checking that they haven't, if in case they haven't been updated in many years, that there aren't any vulnerabilities lying around. And that's what you want to be checking for. So also related to using official base images, you should also be trying to use a minimal base image. So with less code inside, then there's going to be a lower chance for security vulnerabilities. And a smaller and less complicated base image is going to be more transparent to you. So when you're specifying the image, you should take into consideration that the underlying image could potentially be a full-blown operating system. And if your project doesn't require like general system libraries or system utilities, then it's probably better to avoid using a full operating system as your base image. And when we're talking about security, then ideally the base image would be like the best way we think would be starting from scratch, so a completely empty container. But the problem with that is that it's not very practical at all to build your own base image from nothing, and it might actually eventually lead to more security issues because most of us probably aren't security experts, so we wouldn't be able to cover from those. So there's a second best option, which would be, in our opinion, using Distroless, which is a set of images made by Google, and they were created with the intent to be secure. So these images actually contain the bare minimum that's needed for your app, meaning that there's no shells, no package managers, or any other tools that might bloat the image. And it's not going to create signal noise for security scanners, which would make it harder to establish compliance. So also, when you're looking for your images online and when you're pulling them, they can have multiple tags, and often people use the tag which is called latest. So image tags are actually not immutable, and that means that the author can publish the same tag multiple times. And that means that your base image, is going to be changing in between builds, and that's going to lead to inconsistent behavior. So not only that, but if somebody's making changes in the images in between builds, like they could essentially be injecting malicious code, and you haven't explicitly protected yourself from that. So there are some ways to mitigate this issue. So it is preferred that you use more specific tags, and the image can have multiple tags such as like 8 or 8.0.1 or 8.0.1 Alpine, and you'd probably want to use the last one because it's the most specific one. But again, there is something that you'd have to keep in mind when you're using specific tags, which is that it might be deleted eventually. So to cover for this issue, then you should actually consider running a local mirror of this image in a registry or account that's under your own control. So it is important to take into account the maintenance overhead required for that approach, because it does mean that you need to maintain a registry. So replicating the image you want to use in a registry that you own is a good practice, and it's going to make sure that the image you use doesn't change. So even though it may seem like a bit of extra work, it's definitely worth it to avoid the potential malicious code being injected without your knowledge, just because you're blindly pulling from latest and hoping for the best. And finally, another thing that we want to be looking at is the authenticity of the Docker images that we're pulling. So we do put a lot of trust into these images because we're literally using them as a container that runs our code in production. And that's why it's critical to make sure that images we pull is the one that's been pushed by the publisher, and that nobody else has modified it in between. So tampering can occur in different ways. It can occur between the Docker client and the registry, or by compromising the registry of the owner's account to push malicious images into it. And a way to verify that there hasn't been any tampering between your pull and what the image owner originally pushed is to use Docker Content Trust. So we're not going to go into any more detail with that, but that's just what we would recommend, the Docker Content Trust. And Yeah, so now I'm going to pass you over to Monica, and she's going to take you through the next stages of the container lifecycle.
Yes, thank you. So when transferring data among network systems, trust is a central concern. So in particular, when communicating over an untrusted medium, such as the internet, it is critical to ensure the integrity and the publisher of all the data a system operates on. So content trust provides the ability to use digital signatures for data sent to and received from remote Docker registries. Publishers could be individuals or organizations manually signing their content, or automated software supply chains signing content as part of their release processes. So when it comes to shipping the image, we want it to be reliable. So signing your image is especially beneficial if your company has a private registry and you want to make sure only certain people can modify and push image tags, and as well will help prevent the users of these images from working with tagged images unless they contain a signature or comes from a trusted source. So when talking about resources, by default, a container has no resource constraints and can use as much of a given resource as the host kernel scheduler allows. So Docker provides ways to control how much memory or CPU a container can use. And the way to do this is to configure resource quota on a per container basis. So without a resource limit, a container can use up all available memory. If that happens, the host kernel will kill kernel processes to free up memory, and any process is subject to killing. So Docker or any other important applications can be killed. So this could effectively bring the entire system down if the wrong process is killed. So Docker attempts to mitigate this risk by adjusting the out-of-memory priority on the Docker daemon so that it's less likely to be killed than other processes on the system. The out-of-memory priority on containers, yet it's not adjusted. So this makes it more likely for an individual container to be killed than for any other system process or the Docker daemon to be killed. So, but you should not try anyways to circumvent these safeguards by manually setting this adjustment to an extreme negative number on the daemon or a container, or by setting the out-of-memory kill disable on the container. But what are the things that you can do to mitigate the risk of system instability due to out-of-memory? Are perform tests to understand the memory requirements of your application before placing it into production. Ensure that your application runs only on hosts with adequate resources, and limit the amount of memory that your container can use. So setting resource quota is useful for several reasons. It can help to keep your Docker environment efficient and prevent one container or application from hogging system resources, but it also enhances security by preventing a compromised container from consuming a large amount of resources in order to disrupt service or perform malicious activities. But this wouldn't be enough to set resources quota if we don't restrict a container's access to system resources. So in order to have control on who can set these resources, Docker has a cluster management solution. You could use the universal control plane, which is just helps you manage your Docker cluster and applications through this single interface. And there's this specific feature designed to regulate user access to resources. So the process involves organizing your users into teams based on their function. So you can easily assign no access, view only, restricted, or full control permissions. So now that we've known some of the things that we can do to take care while building and shipping the image, let's see what can we do in runtime. So when you run a container, Docker creates a set of namespaces and control groups for that container. This provides a layer of isolation. Each aspect of a container runs in a separate namespace, and its access is limited to only that one. So the best way to prevent privilege escalation attack from within a container is to configure a container's application to run as unprivileged users. For containers whose processes must run as the root user within the container, then you can always remap this user to a less privileged user on the Docker host. So the map user can still function within the namespace as normal, but will have no privilege on the host machine itself. And as for control groups, they are yet another key component of containers. So they implement resource counting and limiting. So while they do not play a role in preventing one container from accessing or affecting the data and processes of another container, they're essential to fend off some denial of service attacks. They're particularly important on multi-tenant platforms. And some of the things that control groups allows you to do are resource limitation. So groups can be set to not exceed a configured memory limit. And this includes as well the file system cache. Prioritization. Some of the groups may get a larger share of CPU utilization or disk I/O throughput. Accounting measures how much resources certain systems use and which may be used, for example, to detect anomalies if the system starts misbehaving. And finally, you can control. So you can freeze the group's processes, their checkpointing and their restarting. And if you want to go a step further, you could use rootless mode. So rootless mode allows running the Docker daemon and containers as non-root user to mitigate potential vulnerabilities in the daemon and in the container runtime. But how does this work? Rootless mode executes the Docker daemon and containers inside a user namespace. And yes, this is very similar to what we've seen before, except that with user namespace remap mode, the daemon itself is running with root privileges. Whereas in rootless mode, both the daemon and the container are running without root privileges. And finally, Docker containers typically rely heavily on APIs and networks to communicate with each other. So that's why it's important to make sure that your APIs and network architectures are designed securely and that you monitor for anomalies that could indicate an intrusion. Since they're not part of Docker itself, but are instead resources that you use in conjunction with Docker, steps for securing these are beyond the scope of this talk. Nonetheless, they shouldn't be neglected. So now Marina is going to share with us a small demo that we have prepared for you.
Cool, thanks. So you might feel like we have just bombarded you with a whole ton of information, and some of it you might have already known, and some of it is hopefully new insights that you can use from now on. But what we really wanted to do was finish our talk with a small and simple demo where we're going to show you two different ways of adding security scanning into your pipeline. So for the first one, you won't need anything apart from a valid token. And for the second one, you'll have to install a plugin in Jenkins. So depending on what your needs are, you can choose what's best for you. For this demo, we're going to be using the tools that you can see here on the slides. So Docker as our container, of course, Jenkins as our pipeline, Aqua Micro Scanner for the image vulnerability scanning, and Hadolint for the Dockerfile linter. We've only chosen these tools for the sake of simplicity. They're by no means the only ones that are out there. Our aim is just really to demonstrate how simple it can be to add the scanning into your CI/CD workflow and integrating it into your pipeline. So just as a really quick overview, we've set up a basic Dockerized app and it gets built in our Jenkins pipeline. And we're building our image from a base image that we found on Docker Hub. And since we've already covered what to look out for when you're pulling images from a public registry, you know that you should be looking for official images and using the right tag that's being supported. So we're going to skip that part. We're not going to use that as part of our demo. So what we are going to do is we're going to walk you through 3 separate commits, which we did prepare earlier, purely so that we didn't have to bore you with watching pipelines run, because that can take some time. And yeah, so let's go through the first commit. For this one, we'll look in our Docker file, and we've made some more obvious mistakes so that we can see how the tools help you catch the mistakes, and we really want to be seeing the scan failing. So in the Docker file, you can see it's pretty simple. We're doing some things that we want the linter to pick up. So we're building from OpenJDK latest, so we're not using a specific tag, as we mentioned shouldn't be done. The next thing is having user as root. So we covered this earlier. We outlined the risks of why your final container should not be running as root. And then the other thing is up on line 3, we're using add, but it's actually a good practice to use copy instead of add. And to explain this a little bit more, Docker provides two commands for copying files from the host to the Docker image when building it. So those two commands are copy and add. Copy copies all the local files recursively, and it's given an explicit source and destination files. And with copy, you do need to declare the locations, whereas with add, it's implicitly creating the destination. It's implicitly creating the destination, even if it doesn't exist. And it also can accept local or remote URLs as its source. And that's going to expand or download into the destination directory. So try to use copy when you can, because it is more restrictive. And it's actually also advised by the Docker documentation that there's only one real reason why you should be using add, and mostly it's for backwards compatibility. So try to always use copy when possible. The next section in the Docker file that you can see is the first implementation for adding vulnerability scanners. So we've added it as a multi-stage block, and the only thing we needed to make it work was a valid token. We won't go through the exact details because setting it up, you've probably got the instructions in the documentation. So depending on the tool you use, it will be different. So next we're going to move on to our Jenkins file. And to start with, we'll have a look at these stages. So first we'll run the linter, where we'll verify whether the base image has been signed. Then we'll build our app. And finally, we'll build our image and scan it. Yep. So now we're going to imagine that we've committed and pushed and the pipeline's run. And now we're going to go and have a look at the output on Jenkins. So you can see that the pipeline's failed. And if we check the output for the linter, we can see that it's telling us that these are the things that we needed to improve in the Docker file, and that's exactly what we were expecting, using the latest tag, not setting user as root, and using add instead of copy. So for the next stage in the pipeline, it's about verifying the signatures on the image. And if you do want to only use images with signatures, then you would need to add a condition into this stage of the pipeline, but we've just left that step out. And then lastly, we can see the build has failed on the scanning stage, but what we're going to do is we'll focus on those details in the next commit. First, we're going to try and fix the stuff for the linter. So yeah, we can take a look at our second commit now. So imagine that we've made these changes. So we started by doing the ones for the linter, which is using OpenJDK 11, which is a slightly more specific tag, but still not ideal. And we've specified a group and a user for this image, and we've replaced add with copy. So now that we've changed the things that the linter was telling us to improve, you might also notice that we've removed the multi-stage block which had the scanner. And this is so that we can show you the second approach, which is adding it directly into your Jenkins file. So let's take a look at the new stages we have in our Jenkins file. Yeah. So we've added the building of the image as a stage using a Docker plugin for Jenkins. And then we'll use the same scanning tool as we had in our Docker file before, but this time we've installed the plugin for Jenkins. And now we just have to specify the image name. So that's the second approach to adding scanning to your pipeline. So now we want to pretend again that we've pushed the changes and watched the pipeline run, and we're going to review the output. So firstly, we'll take a quick peek into the linter, which we can now see doesn't have any new messages, which is great. So that means we've cleaned that part up. Then we'll look at the verify signature stage. So even though we changed our base image, we can see that this one also doesn't have any signatures. And then finally, we can see that the scans failed. And now we want to understand why. So we can take a look into what the result of the scan is. And here you can see that the image is saying, that the scanner is saying that the image is non-compliant. And that's because it has at least one high severity vulnerability. So in this tab here, yeah, we can see all the vulnerabilities that the scanner's found, and it shows you each individual CVE link. So a CVE is the common vulnerabilities and exposures, and it's just a list of standardized names for security vulnerabilities. These are all the publicly disclosed vulnerabilities, and they're stored in this big database, and most security scanners will be checking against it. So finally, if you have any sensitive data or malware in your images, then you would be able to see them in these tabs up here. So now what we want to do is we want to get a pipeline that's passing. So we'll go to the third and last commit. We've kept everything the same mostly, apart from the base image. So we've changed to a more secure base image, which hopefully won't have any high severity vulnerabilities. And as you can see, it's a lot more specific than the other ones we were using. That's the only change we have in the Docker file. So if we take a look into the Jenkins file, you'll also see that the last stage is to deploy an image. So if the image scan passes and the image is allowed, then we'll be able to deploy the image into a public registry. So those are the changes that have been made. And now we're going to, again, pretend to push and look at the pipeline. And let's just go back to the linter just to make sure it hasn't picked up anything new. And it hasn't, so that's great. And then we can go to have a look at the signatures, which now this image does have. And this is something which we wanted to leave out a little bit, because it's just important to see that you can verify that the image has signatures so that you know it's coming from a public, a trusted source. But the way to make sure that all the conditions are run is something that you'll just have to figure out, like you can learn how to do just with some basic documentation. And if we go to the scan, so that's the next part, we can see that it's passing and the image is allowed. So we can also have a look, see that there's fewer vulnerabilities in this one than in the previous one. So you might be wondering, okay, but can I find an image with everything I need and no vulnerabilities? And the answer is most probably not. No, you won't find one, because like, even though we've said in this talk that the recommendation is that you're choosing an image that has like every version of contain, like the bare minimum that you need for your app, you're still going to have some packages and some dependencies. So you're always going to have, well, not always, but almost always going to have at least a few vulnerabilities. But these ones are low and some of them are negligible. So it's perfectly fine to have an image with such few vulnerabilities. And then lastly, we can see that the image has successfully been deployed to our registry by checking it out on Docker Hub. So that was the number 3, and that was the pipeline, the third pipeline that ran. So yeah, that is it for the demo. And I hope you can see how simple it can be to add scanning to your pipeline, and that you do have various options to do so. So adding security scanning is probably the minimum that you can do when it comes to thinking about security in Docker. Like, as we mentioned before, it is the primary means of defense against security flaws and insecure code within your container images. And it really is foundational for Docker security as a whole, as we mentioned before. So yeah, we're good.
And as you see, there are no simple tricks to maintain Docker container security. Instead, you have to think holistically about ways to secure your Docker containers and harden your container environment at multiple levels. So security is not set it and forget it. It requires vigilance to keep your images and containers secure. And if you don't know where to start, then you can start thinking about threat modeling, which is a process where you identify potential threats and helps you prioritize your possible mitigations. So you want to be thinking of security as a feature. So asking yourself the right questions, and every time ask yourself, do we have any security requirements? But what we will want you to take today is that security is everyone's responsibility, and you don't need to spend much time or invest in start investing in a big infrastructure to start making this part of your continuous delivery. And finally, let's just remember to build with the bare minimum and from trusted source, ship with control resources, and run with the right permissions.
Thank you. That is it from us today. And we can move on to the next slide with the Slack channel. Yeah, so we can answer questions that you might have in the Slack channels available and in the Q&A.
Cool, and we have a few minutes left. I mean, we have until 1:15, and there's a few oh, actually a growing number of questions in the Zoom. So I'll start somewhere in the middle. The first question is, what Docker linter do you recommend or use?
Do you want me to take that? Okay.
Yeah, sure.
Well, we used Hadolint for this one, and it does have integrations with some IDEs. So that one is a good one. But I think essentially like just looking at what tools suits you best is probably ideal. But Hadolint is a good place to start.
Cool. There's a question by Pablo. How can we manage future vulnerabilities of Docker images which pass the test when it was built in the past? So I guess what he means is the pipeline runs, it passes the test, it's deployed, and then a vulnerability.
Yeah. So I think this is a really good question, because so what you should do is like reveal your images constantly, right? Like this continuous deployment, just not let it go too longer or too much time until you rebuild again. So you can continue scanning and detect if there are new known vulnerabilities.
Yeah, maybe as a follow-on question then, anonymous attendee says, people used to brag about the uptime of their servers. Should we now be doing the other way around and make sure our instances are regularly rebuilt so that we know they're the result of fresh scans?
Yeah, I mean, I don't know, Marina, if you have anything else to add to that, but I would say, yeah. Yeah, I mean, I think as a good practice, you should not be like reveal constantly, right? Your images or your applications, so you can detect every time new known vulnerabilities, because probably you won't detect them all at first, right? So it's a continuous improvement.
Cool. So Mohit asks, says, thanks for the demo. How about security in the context of Docker Compose or in a cloud container orchestration environment?
So I would say that that's something that we would want to answer if we looked into that further, but because there are so many layers, then that's not something that we focused on for this talk, but we're happy to get back to you with something maybe on Slack. Would that be cool?
I guess. So Theo asks, what kinds of criteria do containers and their publishers need to fulfill in order to be certified or verified?
Yeah, so there is a list. I don't know it by heart, but yeah, there's certain things that you need to do, and there are different steps, right? Like you can be certified by Docker, or you can be an official publisher, and yeah, they all have different constraints. Again, like on the signing images and verifications, we didn't go really deep on it. We just wanted to show that you quickly can at least inspect and verify that they come from a trusted source. But becoming a certified or official publisher, like you can go back to the Docker documentation. It's all pre-explained there.
Yeah, this was about 15 minutes in your talk. I think there was something that you mentioned specifically that the question came about. Somewhat related, should registries have a responsibility to only host images which pass a baseline level of security?
I mean, I think that would be good. Yeah. I guess that's, yeah. Sorry, I'm trying to think of the answer, but
so I can
yeah.
But so
Okay.
I would say that yes, that'd be great. But then I think that falls into the area where, okay, so we want to promote open source and a lot of open source, and then you just start putting constraints, right? So I guess it should be a balance where people can then contribute to registries or private registries, depending on who is owning those. But so the security, it should be a minimum of security on this, right? Because then you are like publishing this to a whole other people that will be trusting your registry and using this as like not blindly, but like trusting that you put in place some kind of security. So I think, yeah, should be a balance. Maybe not, it's not all their responsibility, it's as well our responsibility to take care of the things that we're contributing, I guess.
Cool. And then the last question, a bit of an open-ended one. If we are not using container scanning on our projects in 2020, should we feel bad?
But do you want to answer?
Oh, yeah, are we allowed to say yes? You should feel terrible. You should be scanning, and we've just shown you how easy it can be. And it really is just a few steps, and it can pick up some really important stuff. So it's not going to take a lot of your time to add it in. And if you can go and do it right now, add it to your project, go do it.